Yeah, you can start, ma'am. Rami, ma'am?
Yeah, shall I stop sharing and then start so that it would be
Yeah,
easy
yeah.
to continue? Yeah, that's what.
Okay,
Just a
yeah.
minute. Okay.
You can start.
Good morning, everyone. Am I audible?
Yeah, audible,
Yes,
ma'am.
ma'am.
Yeah,
Audible.
fine. Okay. A warm and cheerful welcome to one and all here, gathered for a generic talk series 36, organized by RMK College of Engineering and Technology. Today's talk actually focuses on an exciting and a futuristic theme, designing modern platforms for the age of AI. In today's rapidly evolving digital world, data has become the lifeblood of every organization. So, the way data is collected, processed, stored, and analyzed plays a very crucial role in powering the artificial intelligence applications. This session will help us understand how these modern data platforms are architected to support our AI driven insights. We are truly privileged to have with us Mr. SELVARAJ Ruban, Consultant Modern Data Platform Architect, Tata Consultancy Services, a seasoned professional with deep expertise in modern data systems, cloud integration, and AI analytics. His talk will certainly inspire us to explore the technological backbone that makes the intelligent systems possible. On behalf of our management, principal, and the Department of CSE, I extend a heartfelt welcome to our principal, deans, head of departments, faculty members, and all our students joining us through YouTube Live. To formally begin today's proceedings, I'd like to invite Dr. Rajaguru, the head of the Department of Computer Science Engineering, to deliver the welcome address and introduce our chief guest. Sir, we request you to address the gathering.
Thank you, ma'am. Good morning to one and all present here. On behalf of management, principal, deans, HODs, faculty members, and students of RMK College of Engineering and Technology, I extend a warm and cordial welcome to everyone joining us today for the Generic Talk Series 36 on the topic Designing Modern Data Platforms for the Age of AI. We are truly honored to host this insightful session as a part of our continuous efforts to bridge the gap between academia and industry and to expose our students and faculty to emerging trends in technology. It gives me immense pleasure to welcome our distinguished speaker for today, Mr. Selvaraj Ruban, consultant and modern data platform architect at Tata Consultancy and Services. Sir, welcome you, sir.
Thank you, sir. Thank you for the
Mr.
warm welcome.
Selvaraj Ruban is a seasoned data professional with over a decade of rich industry experience in data engineering, modern data platform, artificial intelligence, machine learning, and genetic AI framework. He has played a vital role in designing and implementing enterprise scale data platforms for global organizations across domains such as aviation, transport, banking, and finance. An alumnus of RMD Engineering College, Mr. Ruben holds a master degree in computer application and has further strengthened his expertise through an advanced postgraduate diploma in machine learning from IIT Madras. His technical proficiency spans cloud platforms such as Azure and AWS, big data ecosystems including Databricks, Snowflake, and Apache Sparks, and advanced AI solution leveraging LLMs and Gen AI architectures. Through his professional journey at Tata Consultancy Services, he has contributed to building modern data lakehouse architecture, AI power analytical solution, and scalable data platform that enable organization to harness the true potential of data in the AI era. We are confident that today's session will provide a valuable insights into modern data platform design, AI-driven architecture, and real-world industry use cases, which will greatly benefit our students, researchers, and faculty members. Once again, I extend a warm welcome to our esteemed speaker, Mr. Selvaraj Ruban, and to all the participants joining us through the RMKCT YouTube live stream. Thank you all, and I wish everyone an engaging and enriching session. Sir, the session is yours, sir. Thank you, sir.
Thank you, sir. Thank you for the warm welcome. Yeah, good morning, one and all present here. And myself, Selvaraj. I'm the alumni of RMT. I think Sar has given a very brief introduction about me, and I have over a decade of experience in managing database systems and data platforms for different business domains and clients in my career. With that, in today's session, I want to cover up on the intuitions behind why we are emerging the modern data platforms and what benefits out of that the enterprises will get to feed into that AI and ML initiatives that has planned as part of the business. And not more on the data engineering perspective, because there are already some generic talks happened on the data engineering side. So I want to skip and go more over on the how we can data strategies and management to the enterprises. I hope my screen is visible to everyone.
Yeah, sir, it's visible.
Yeah. Okay. So with that, with the introduction, yeah. So mainly I will traverse from my experiences over how I have grown from the traditional data systems to that the data lakehouses and forming the big data platforms, and how the recent technologies has been evolved into that the intelligence. It's called intelligence platform with all the AI and BI capabilities enabled. So I will try to traverse through and get the intuitions behind that. So that's the main motive of this session today. That said, we will little bit warm up with the traditional data ecosystem. So, for example, we can take a enterprise. For example, we can take any company, and the company have different kind of domains and business units within that. So these are the common business units we can see in any domains: HR, finance, inventory, sales, and maintenance. So in traditionally, we have to maintain a separate applications where are the ERP platforms to feed to digitalize all these domains. So each domain, it will have that the its own application and server. It will run on the backend legacy database systems to capture all data coming in and in out of that business. So in 20 years back, we are deriving all the insights and analysis from using the data warehouses, where we have to collect all the data from various different nature of systems to a single place. In data warehouses, it will have that own principles and guidance to model and build their reports. The main challenge is here is like each system, it has its own nature of technology tools and applications. For example, uh, the sales is a very highly maintained application where I want to keep Oracle as a database system, because Oracle provides a very low latency transactional processing capability, whereas HR may be the low priority. I don't want to spend for the spend much cost on the enterprise licensing as like the sales one. So I can go with the MySQL for the HR. So each system, it will have a different technology stacks, and it will have for sales, it can have a Linux, and for finance, I can have a Windows machine. So each are bounded with the technology limitations, and to bring the data to that data warehouse, we have to do that lot of ETL complex logics to bring data over to the data warehouse and build reports. And even the data warehouse also, it's not a single one. Organizations will have a different for their to fulfill each business units and their needs. So the main problems are like the data is scattered. We will have the repeated data or duplicated data every different applications, and all the other ETL logics were batch oriented and it's very slow. We will run nightly jobs for hours and hours to bring data from one application to the main data warehouse, and operational overhead. So each application, we have to maintain a separate admin team and infra team to maintain the underlying OS batches and the database systems, and the databases will go through every 3 months once patching. So it will be very complex to maintain the applications and data all together as a company perspective. And on top of that, so in 2020, after 2010 onwards, the big data platforms coming into place a major role, because we were a lot of social platforms and a lot of data generation happened during that time with the different technology tools like mobile applications and different SaaS products. So the data is getting varied into different nature, and the volume also it was growing. But my traditional systems are not able to handle those much of volumes and different nature of data. So in the old systems, it will always be the data is coming in the very perfect format, which was already uh, quality applied in the front end applications. So in the backend data, it's almost clean. The analysis team, they don't want to spend much time on the data cleaning and processing stuff. Whereas when the big data systems come in, the data is uncleaned, um, mostly on the raw text we will receive from the XML or JSON files. We have to clean before we store it in a format, and we have to apply the schema in the data warehouse in order to get the benefits. So as an organization perspective, it will be very cumbersome to maintain all these systems and data together. But later, 2010, we are starting with a AI, AI era where the data is mainly become oil to the AI engines. So in some way, we have to get all the data together and centralize it, clean it, and feed it to the AI training, AI and ML models. To solve that problem, big companies has evolved to bring the big data platforms such as Hadoop. So initially, the Hadoop systems were very become popular because of the nature and um, uh, how the Hadoop came into the system to mainly decompose the limitations of the bounded servers. So in the bounded servers, we will have the underlying storage where the actual data will be residing in, and the CPU where the compute power will be processing on the data in the storage, and all the business logic it will be residing in the data warehouse in form of the code. So mainly they try to decompose all these three components into different layers. The storage becomes the HDFS storage block. It's a Hadoop file-based system. It will be stored in block and blocks in the storage. Whereas in the CPU, instead of a single CPU, we were introduced with the distributed CPUs. Whereas a group of servers will become act as a CPU, and all those servers are managed by the cluster manager utilities to perform all the processing and bring the results. And in the data warehouse business layer, it becomes a map reduce applications where it will process the data in a master slave architecture in Hadoop. So it was pretty well with the larger data sizes at the initial point of time, because each block has 128 MB of size. The bigger files fit into that very well, but uh, if if we want to process a very smaller chunks of files, whereas the problem arises because the smaller files, it was very shuffled across multiple blocks. The processing of those files with the CPUs leads to higher I/O, and it increases the latency of the processing. So initially it was very well, and later point when we are more rushing to the real-time analytics and more incremental and the delta processing, it's a problematic systems we face with the Hadoop. And also to manage all the distributed networks, it's a very difficult job to tie up all the networks between each servers and collate all together and bring the fault tolerance nature. Everything is become cumbersome to manage all the servers in the cluster. So and also the data governance side, there is no much access control applied at that point of time. So it's very limited, and for organization perspective, they have to maintain separate access for the applications and database and as well as the big data platforms. It's not all unified in a single governance protocol. So that's another challenge faced by the Hadoop systems. So to mitigate all these challenges, um, the companies has introducing the Spark architecture. So the Spark is the real game changer in the big data platforms. So what it does, so it still manages the cluster manager to manage all the distributed clusters, distributed CPUs. Whereas in Hadoop, the data processing will happen in that small amount of memory that is RAM, and um, if the data is more to fit into the RAM, it will fall back to the disk. And every time the business layer, when it applies the map reduce, it has to read data from block, and it has to keep it in that CPU for processing. And at the time, once the map done, the data will return back to the block again, and in the reduce it will read again. So there are a lot of read and write operations in the STF storage, which was one of the main reason was of the high latency. So to avoid that, Spark introduces the driver and worker architecture, where it manages all the tasks within a single within a in-memory processing, which means that we will have the higher amount of RAM comparatively with Hadoop in Spark, and the all the tasks it has been ran in the C console in Spark, whereas in Hadoop, yeah, the task will be splitted, and each task it will go back from RAM to disk. Here, all the tasks are been sequentially processed, and once all this done, then only the data will be placed into the disk. So there is less I/O between disk and RAM, and the latency was very higher. Uh, so in technically, it yields 100 times faster than Hadoop systems. So this is one of the main benefit we gain from the Spark engine processing. Whereas, so this is the typical architecture where the Spark comes in. It will have the driver node, and it will have that multiple worker nodes, where driver, so each one is a different servers, whereas the driver will coordinate with all the worker nodes. And all these servers together is managed by the cluster manager utilities, which was supported by the Hadoop Yarn mesos, and we can use it as a standalone or with a Kubernetes orchestration. So when the task is coming to run, the driver node, the Spark context initializes the task, and it will split into multiple partitions and pass it to the workers. So the worker, the Spark context, it also forms a DAG style execution, and it passes to the worker, and worker will execute the task in the sequential and send back the result to the driver to compile together and write back to the disk. So this yields a very high performance. And the storage side, in the Hadoop, we have to maintain all the data in the HDFS. We have to bring everything. Suppose if I want to process for the HR finance applications, I have to bring the data to the HDFS, and then I have to apply that the data transformation or the data cleanup utilities in the business layer. Whereas in Apache Spark, it provides the multiple data source APIs, where it can read data from any different data sources. So I can read from any data warehouse or PostgreSQL databases, or any cloud object stores like Azure Blob, Amazon S3. and other NoSQL databases as well. So this gives more flexibility to bring the data to the data platform very quickly, and it overcomes the challenges of the Hadoop. So the cluster and the data storage and the business layer. So this in the business layer also, whereas in Hadoop we have to write our own business layers, and we have to rely on that the different open source tools like Hive, pick like that. We have to maintain with the different technologies to process the data. Whereas in Spark, it fundamentally provides the programming capabilities with the Java, Python, or and SQLs. So one of the main benefits we yield from Spark is like the streaming nature, whereas in Hadoop it's completely batch oriented and is less fault tolerant. But in Spark, it's highly batch oriented and also supportive to the streaming nature. So with the programming side, the R is used for mainly for the data researchers or data scientists who will apply the statistical functions over the data. And Python and Scala mainly used for all the developers to write all the data ingestion and transformation logics. And SQL mainly used to derive the data analyst part. It's mainly used by the BA or data analyst teams. And Java is fundamental to the Scala. So we can write Java applications, but many of the developers in the recent times, they use the Python with the Spark, which is called PySpark here. So it's a combination of Python and Spark native processing together. So we can combine the data frame processing and Python together in a PySpark API. So it gives some more flexibility to develop applications and deploy it in the data platforms. Along with that, it provides machine learning capabilities where we can build models on top of that, the data on top of the data we store in the data marts, and it provides the graph computing power as well. So out of all these benefits, out of all these benefits, it paved the way to build a modern data platforms to inherit all the to supply the data to the AI and ML models, and in the recent times with the agentic workflows as well, it mainly supports. So all the data platform in the current market, they were trying to utilize the Spark as the core engine. They slightly avoiding Hadoop in the backend. So like we discussed in the last 3 slides, the core components of the modern data platform arrives in mainly in the data side, how we are keeping the data. If you think about the Oracle and SQL servers, where the data will be maintained in their own formats. Oracle maintains in a .dbf format, and SQL Server maintains in .mdf format, where it's proprietary and it's a very binary format. We cannot read it, and it's not supportive. It's not portable to the other platforms. So if I am using Oracle database, I cannot just bring the data in the DBF file to the SQL Server and use it. So that's why the open data formats came into the market to become more portable, more data sharing to enable more data sharing capabilities. So Apache Parquet is one of the main format utilized by many companies, where it's a columnar data format and it's an open format that can be portable to any data platform system. So with the nature of the recent the acceleration of the latest technologies, more open source utilities become into the main picture, because it provides more technical benefits and bigger community to support and to support. So here we can see all the main components are backed with the open source components, which is more powerful and has a big community supports. So in the data side, we will have that Parquet, and along with the Parquet format, there are other formats as well are very popular, like Apache ORC and in the recent times Iceberg and Hoodie data formats. So these serves different benefits. Like Apache Parquet, it's an open columnar format. It's very fast for the read operations, whereas ORC is or more on the transactional side. Um, and and in the storage also, it's a very scalable storage, which is supported by the cloud platforms. Whereas in Azure, we will get the Azure blobs, and AWS, we get that the S3 buckets. We can extend as much as quickly rather than I ran in the Oracle systems. There is a limited storage capacity by the hard disk or SSD within the server. But with the cloud storage, I can scale up multiple times. And in the compute side, also it's with a distributed nature. It can be scalable horizontally. We can add n number of nodes in the distributed clusters at any time. We can scale up and down whenever it's required. Whenever it's required, we can just start and off. Unlike the old database systems, I don't need to up and running for 24 hours. So with the latest data platform, I can just start the compute whenever needed, and I can switch it off. And it's a highly fault tolerance because the Spark works on with the underlying RDD capabilities. RDD is the resilient data distribution capability. So basically, it tracks where the data originates from. So in case of any failure in the task executor, it will go back and get the data quickly. So that the any executor got failed, it will quickly spin up the other executor, and it will get the data from the data nodes. So in that way, we achieve the highly fault tolerant systems with the compute side. And with the data governance side, there are a lot of data governance protocols comes into the picture with the latest cataloging technologies. So governance, mainly we bring that access control. As the company, I want to know what data is accessed by who, and I have to apply the strictly policies and the security masking and encryptions to restrict the data outflowing to any unauthorized access or users or any other AML systems. And as well, I have to audit uh, I have to audit the data flows and data usage and monitoring as well. And the data lineage and time travel is the another benefit from the governance side. So the lineage with the end data with the end data format, I can go back and trace back to the data source where it originates from. In that way, I can quickly trace back and get where the data originates and how to fix if in case any fix needed, I can fix it. And time travel. So in old systems, we will take the backup and restore to achieve the time travel. But wherein in the modern data platforms, each transaction is captured as a versions, and we can quickly time travel back to the older versions very quickly. And it also comes with the AI support. So nowadays, although the platforms are trying to inherit the LLM models, which is the natural language processing, applying the natural language processing to get insights from the data. So these are all the core components which the modern data platforms trying to inherit. And I have taken one example from the Databricks because the Databricks is it's the biggest data platform currently in the market. So this is the overall structure of the data platform. So this one, it's backed by the Azure components, but it's not necessarily to be Azure. It can be AWS or Google Cloud platforms. So here in the data side, we have a different nature of data. So like in the traditional databases, I have that the relational databases, we can bring data from SQL, Oracle, or any RDBMS database. And the unstructured databases. Unstructured data sources, it's mainly from the blob storage or the S3 buckets. We can bring any videos or audio formats to the data platform. And semi-structured data as well, the XML or JSON data structures we can bring in, and any event streams like Apache, Kafka, or Azure Event Hubs. Um, those are the main streaming event hubs in the recent times. So we can integrate with the streaming data sources efficiently. So in the ingestion side, it supports the batch ingestion and as well as the CDC. So the CDC is the change data capture. Whenever the data is getting changed from the source, only that data will be bringing to the data platform. And the streaming ingestion, whenever the new data is getting generated, it will be appending in the streaming mode. So with that, all the data integration is very efficient. We can bring any type of data into that data platform. Uh, and foundationally, we are running over the Apache Spark, which is very efficient and faster in terms of processing in all the workloads with the batch and incremental. So the underlying storage, it will be on the cloud platforms like Blob or S3 bucket files. On top of that, we have that the Unity Catalog. Unity Catalog is a data governance tool which controls all the access controls over the data in the storage, and it applies all the auditing and monitoring and time travel capabilities. And Delta Lake mainly, the Delta formats mainly comes with the ACID properties, whereas in older days with the big data systems, there is no ACID compliance. We can just append data and read data. We cannot perform update or modify in the existing data. The cost of doing that is very high, but with the Delta properties, we can achieve all the ACID compliance within the data tables, so that we can use a big data table like a normal table in that Oracle or SQL Server with all the properties enabled. And on top of that, we have our the ETL pipeline. So this is a common pattern followed by all the organizations, but not necessarily to be maintained in the same way. It's a ELT structure where we bring all the data to that in a single raw form, and we will apply all the data quality rules and the business transformation logics into the silver, where it becomes the data is very cleansed, and in the gold we will build the data marts which will be consumed by the uh, business units or the analytics teams in a very clean and neat format. Um, so in gold, we will be applying all the data model properties where all the star schema or the snowflake schema with the facts and dimension tables will be playing the major role for structuring the gold layer. So with that, we bring all the data in a very neat format, and on top of that, also it provides capability to develop the ML models. We can build our own models on the data we process, and we can deploy and serve to the end customers. And Databricks SQL is a data warehousing capability where uh, all these the Delta Lake Unity Catalog support. The Databricks SQL, it provides a data warehousing capability. So it sits on top of the gold layer, and it provides all the data warehousing capabilities to the analytics and BI platforms. So this data warehouse, it maintains a separate server architecture, where in the previous cluster management, I have to spin up the driver node and executor node, whereas this comes with the serverless architecture. The servers are reserved by the Databricks, and it can be spin up within a seconds. Rather, in the cluster manager, I have to wait for 4 to 5 minutes to spin up all the nodes and do the job. So with a gold layer, Unity catalog, and Delta Lake properties, so we can build our own OLTP transactional processing databases within data platform rather than going to build over that the old Oracle or SQL Server databases. So that capacity now comes into the picture. On a overall, it's a completely unified data platform where it helps to build our OLAP and OLTP databases, and on top of that, build our data marts and AI and ML models. So it fulfills all the legacy features, like building a reporting with the reporting any reporting tools, and AIB Genie is a inbuilt LLM tool provided by Databricks to interact with the data with a natural language. So we no need to write any SQLs to perform the data retrieval. Rather, we can interact with the natural language. And data sharing, the data is open formatted, so we can share data with any organization in the world who is using the Databricks platform. So there is no ETL or ELT frameworks or tools required between the data sharing. So the data sharing becomes very easy with this platform. And Microsoft Power BI is the governance platform provided by the Azure. So it's for all the Azure components, including all the Azure Blob, the SQLs, and the Databricks. So within Databricks, the governance protocol is managed by the Unity catalog. And in the cloud platform wise, these are other supplement tools which helps to deploy and maintain the data platform. And Microsoft 365, it provides all the Power BI capabilities where we can build the Power BI reports and Power Apps to automate any process or task. Microsoft Entra ID, we call it as a IAM, Identity and Access Management, which is a single identity management tool across all the components. So in generally, all the organizations in the recent times, they are trying to, they were using the Microsoft Entra ID because every organization, they are using that Microsoft Teams, and they want to centralize all the access controls. And this Entra ID, it helps to enable centralized access control across all the tool stack and technologies. So there is no separate maintenance of access controls required for the unlike the legacy applications. And cost management, we can see how much is cost is occurring for each resources in the cost management monitor. And Azure Monitor, it helps to track the logs. Azure Key Vault, we can provides the capability to store highly confidential data, like the passwords or secrets we can manage in the Key Vault, which can be accessed across all the platforms, including the Databricks. We can integrate the Key Vault, and we can centralize all the access controls. And the Azure DevOps and GitHub, it's a source code version control tool where we can maintain all the source code logics in the repo. Microsoft Defender for Cloud, it comes with the default security, so there is no need to worry. So this is the main components in the Databricks. So this architecture and all the components are followed in every data platform. So what are the benefits we achieve? The first benefit is the single source of truth. The data is not replicated; it will be residing in a single place where we can build all the different OLAP and OLTP applications, and it unifies all the components like the BI tools, OLTP applications, and AI/ML models. So the data is single source of truth, which resides in a single table, a single database, and it can be served for multiple purposes. There is no additional storage cost I have to pay, or I have to pay any software licenses or any dedicated servers to maintain all those. Everything comes into the single umbrella. And secure governance, all the governance utilities managed by the Entra ID. As a company, all the department and people who are all using and their access control with the different roles, I can manage with the Microsoft's IAM Entra ID. And all the data platform tools, underlying tools are open source, so that we no need to be stick with the one platform. There are multiple options available in the market, so we can easily quickly move away and portable to the another vendor easily. And the scalability by nature it comes, so we no need to worry on the scalability side in terms of storage and compute. So these are the highly occupied data platforms in the market in currently. Databricks comes into the number one. The reason being is Databricks completely using their customized Spark engine, because the founders of the Databricks founders of the Databricks who are all originally developed the Spark in the Apache Spark project. So their Spark version is 10 times better than the other competitors. So the Databricks leads the market in the recent times, and followed by the Snowflake. Snowflake was introduced like a data warehousing SaaS platform, but later it tries to adapt all the modern data platform capabilities in order to cope up with the AI and the ML models. Also, the other cloud providers also have their own platforms. Azure having the Synapse Analytics. Now it is called Azure Fabric, where it provides all the data platform capabilities. And Amazon Redshift is another player, and Google BigQuery from the Google side. Okay, that's all I have for today, and I will try to show a Databricks and get some idea about how it is working. Please raise me if any questions whenever required. So this is the Databricks platform. So by nature, it's a cloud native. We no need to set up our on-prem clusters and servers and install any softwares. We can simply sign up and run our workspace quickly. So now I'm with my community edition. So here in the left side, we can see that the compute, where we talked about the distributed compute architecture. So all these the compute components are residing in the compute, where we can build the clusters or build a SQL warehouse. So the SQL warehouse is the serverless one. So this is the community edition. That's why I don't have the capability to build the cluster here. But in the enterprise version, we will have that. We can build a cluster here with a number of nodes, with the minimum and maximum nodes. It can scale, and what is the ideal time, and with the tuning options. So all the clusters we can configure in the compute, and these are all the data storage integrations. So Unity catalog, here in the catalog side, it's running behind the Unity catalog, which is managing all the data governance layer. Here we can see all the databases created. So here we can see all the properties of the Unity catalog, like tracking the history and lineage. So I got to select the compute. Now I am selecting the serverless compute, which was shut down by this time. But when I click start, it will be starting in within seconds. So now it started. So it's just a sample data which I was created as part of some notebooks. So this is the sample data it will bring, and the details of the storage, who created, and what is the delta properties we can see here. And mainly the permissions who are all having the access, and we can restrict or we can extend the access to the any other team with the intra ID. Also, we can apply the policies. We can time travel with the histories. So here, each transactions, like I said, it will be maintained with the version and timestamp. So I can roll back at any point of time to the previous versions. And data lineage, I can quickly see this data has been used by who and all, and what are the upstream and the downstream systems. So here I can see this notebook, and this notebook has the code to insert the data into the table, and this is the job. This job which runs this notebook to insert the data, and this is the volume. So the volume provides the blob capabilities to store the files and things. So I kept my files in the volume. From the volumes, this notebook, it reads data with a Spark engine, and it inserts in this customer table. So this is a simple job. We can track. So like this way, we can track the lineage, data lineage to the source. So insights is the BI capability, and data quality we can enable and see if there any abnormality in the data. We can see here. So this is the Unity cataloging function. So to maintain all the business layer codes, we got to go to the workspace where all the business logics, and if you build any pipeline or notebooks or the packages, it will be residing in the workspace. Or we can integrate with the Git to store in the Git and bring and run notebooks here. So all these, the workspace, catalog, and compute, it provides the capability to achieve all the data processing engines. And in the jobs, we can schedule it and run the pipelines. Okay, so these are the main core components we achieve. And in the marketplace, it powered with the delta sharing. So where it provides capabilities to share data with any organization who are using the Databricks platform. So here we can see the free one and licensed one. As part of the organizations, they can build the data models, and they can sell it to the other organizations. For example, take example of our BSE, Sensex, and Nifty. They have the common all the stocks, tickers, and their daily values. But all the brokerage companies, they want to get the data. They can build some models and quickly share to all the brokerage companies from the Sensex point of from the BSE Sensex. So with the free one, we can quickly use. We can just click on get instant access. So this is the table which was developed by National Centers for Environmental Information, but we can access their data from our workspace within a seconds. So with the simple clicks, now I can see all the data from this table. So this is the for the data sharing. And in the SQL side, it provides all the capabilities to build the business intelligence and the reporting dashboard capabilities. So it comes with the SQL editor. We can query the tables as a normal SQL queries. we can view inside our delta. We can perform all the operations in the queries. So likewise, I can write my own application queries and logics to build the reports. And Databricks provides a built-in dashboard capability, but it's very limited, not much like the other platforms like Power BI or Tableau. But still, we can, for simple reports and dashboards, we can build one in the dashboards. And Jenny is the Databricks LLM space where we can interact with the data sets with a natural language. For example, this one for a bakery. So I have the tables, the underlying tables, like the customer, sales, franchises, suppliers, and transactions. So I have to embed all these tables in this Jenny space. If you want to give any specific instructions on or guidance, we can add them in the general instructions. Like I'm saying here, total price column is revenue and sales value, so that it will understand it quickly. So these instructions will add more accuracy in terms of the response. For example, if I want to know how many customers I have in so this underlying the LLM model, it will have the thinking and reasoning capability. It will add all the meta instructions. So this is the total customers. So now it goes to the transactions and the franchises together and bring all the customer counts. So I no need to write any SQLs to get this like in the traditional times. So so this is a small capability comes with the data platforms. And with the AI ML, we can build our own models and train the data within our org and share the models to the end users. So as a whole, I can achieve all the data integrations and data cleaning and modeling, building a data warehouse, and building AI ML models. Everything I can do achieve in the single modernist platform. But then each place it will go deeper. But this is a very high level session on what are the components involved and how we are utilizing them. But there are a lot of way in the future. So each component has its backed open source capabilities. When we go deeper, there will be more learning and optimizations will be applied. So like the Databricks one, the Snowflake also having the similar capabilities. They will also provide all the cataloging and Jenny space, but the naming will be different, but all the principles and the core components will be in the similar nature. So every organization in the recent times, they are trying to adapt into the modern data platform to optimize the cost and to fuel their AI and ML needs. So what happens, this Jenny space, it will become act like a agent service to any of the other platforms. In one of my customers, they build Teams chatbot, where the chatbot, it will integrate with the Jenny space via the MCP protocol. So the chart has been built by the Azure Copilot Studio, where the Copilot Studio and get all the details, get all the results out of this LLM to feed that the agent in the Copilot Studio. So like this way, the integration are happening in the currently in the market. Ourselves on a daily basis to cope up with the all the futuristic models. With that, over to you, ma'am.
Okay.
Yeah.
Thank you so much, Mr. SELVARAJ RUBAN. It was really an insightful and engaging session today. The way actually you explained the principles of the data platform design and link them to the real world AI applications was truly enlightening. And very special thanks for the wonderful live demonstration on Databricks. It was helpful to clearly visualize how the modern data platforms are developed and how it is integrated into the AI driven workflows. We sincerely appreciate the effort, the clarity, and the practical insights you shared with us today. Now, the floor is open for questions for the audience. Participants may post their queries in the YouTube live chat box too. Any questions? I guess we have no questions in the chat boxes. So, shall we any questions? Okay. So to conclude today's program, I invite Ms. Charumita, second year computer science engineering student, to deliver the vote of thanks. Charumita, you may
Yes,
continue.
ma'am.
Yeah, you may continue.
Respected dignitaries, faculty members, and dear students, at the outset, I extend my sincere thanks to our esteemed speaker, Mr. Selvaraj Dupman, consultant and model data platform architect at Tata Consultancy Services, for his insightful session on designing modern data platforms for the age of AI. His practical perspectives and industry experience have truly enriched our understanding of modern data architectures. I express my heartfelt gratitude to the management and principal of RMK College of Engineering and Technology for their continuous support and encouragement. My sincere thanks to the organizing team and faculty coordination for their dedicated efforts and to the technical team for their seamless live streaming of the session. Finally, I thank all the faculty members and students for their enthusiastic participation. With this, I conclude the vote of thanks. Thank you.
Thank you,
Thank you.
Charumita.
Thank you,
Thank
ma'am.
you. With that, we come to the end of our generic talk series, number 36. On behalf of the entire RMK CET fraternity, a heartfelt thanks once again to Mr. Selvaraj Ruben for his inspiring session and highly informative data bricks demonstration. We also extend our sincere appreciation and thanks to our principal, deans, head of the departments, faculty members, and all our student community for their participation and support. We look forward to seeing you all in our next session of the Generic Talk series. Thank you, everyone, and have a wonderful day ahead. Thank you once again. Thank you,
Thank
Mr.
you, everyone.
Selvaraj. Thank you. Thank
Thank
you.
you, ma'am.
Thank you.
Thank you, ma'am. Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, ma'am.